Hello everyone. I'm honored to receive your invitation for this fifth GTSS event, and I thank especially Professor Calafat. Um, I apologize for not being able to deliver this series of lectures on live streaming. The reason is, as you may understand, that the emergency worldwide raised the number of commitments for each of us, and so I'm really full of those commitments. So anyway, I wanted to do my best for helping this event, and here we are with this mini course. Hope you like it. Feel free to ask me any question. This is my email, Simone dot Calamai at unifi dot it. Capital or lowercase makes no difference. Well, so I'm very happy that Professor Pingali is delivering a course on the Calabi conjectures, and in this first lecture I would like to deliver some motivations for our mini course. So as a slogan we could label our first part, so those motivations, as Khler Dream, which is kind of a counterpart of the Calabi conjectures. So what do we understand for Khler Dream? On every compact, smooth Khler manifold there exists extremal Khler matrix on each Khler class. So the first line of this statement is actually fixing the object hereafter M will be compact, smooth Khler manifold of fixed complex structure. Okay? Then what do we mean by Khler matrix? Here we don't want to, for these motivations, we don't want to give the precise definition of extremal Khler matrix. Rather, we would like to give a table of dependency. we have the very important Kähler-Einstein matrix, abbreviated as key matrix, which are special cases of constant scalar curvature Kähler matrix, abbreviated as CscK matrix. And so, as Professor Pingali will say in his lectures, Kähler-Einstein matrices are both Kähler and Einstein in the usual sense of physics. Constant scalar curvature Kähler matrix, they are both Kähler and also constant scalar curvature in the sense of Riemannian geometry, just as for the in non-Kähler setting the Yamabe problem, which has a different equation and it's a totally different story from this. Then finally we have in this table of dependencies that constant CscK matrix on their turn are a special instance of extremal Kähler matrix, which we like to abbreviate as EK matrix. Finally, on each Kähler class, some remark on this point as well. So, Kähler-Einstein matrix need, as Professor Pingali will say, the Kähler class to be so-called canonical, a multiple of first Chern class. Instead, for CscK and extremal Kähler matrix can be defined on every Kähler class. So there is a story about this, and Calabi liked to say every Kähler class was born equal, just like similar as in the human rights principle. Now we could ask the following question: why didn't Calabi dream a similar dream for CscK matrix? Let's write it on the board. Okay, the reason is that sorry, the reason is that the okay, sorry. The reason is that the already in the 50s, Lichnerowitz found that if omega is CscK and the algebra of the holomorphic automorphisms of M is not trivial, then it must be reductive. Meaning that is direct sum of abelian and semi-simple algebra and one semi-simple algebra. Okay, then a very basic example, the blow up of CP2 at one point doesn't pass this obstruction. As consequence, blow up at one point of CP2 has no CscK on any Khler class. Then we see that already in the 50s we can say a similar kind of dream could not stand. So why Calabi, next question could be why Calabi came up with his dream. In the 80s, Calabi proved that the blow up at one point of CP2 actually extremal Kähler metric on every Kähler class. And so did his dream last long? Unfortunately, no, because Levine in the 80s again used a similar abstraction namely extremal Kähler implies that the extremal Kähler and the algebra of holomorphic automorphisms non-trivial implies that the group of holomorphic automorphisms has compact subgroup. To show that CP1 times CP1 blown up at suitable points has no extremal Kähler matrix on any Kähler class. Now, I guess Calabi's heart was broken after this news, but next question on the board is Levine example the end of the story? No, actually, because in the 80s the relevant problem on existence of Young-Mills connections was, we could say, tackled related to an algebraic notion the slope stability in order a correspondence between stability and existence. So kind of a bridge between an analytic viewpoint and an algebraic viewpoint. This is called the Kobayashi-Hitchin correspondence. Later, this correspondence became theorem. The Yau-Uhlenbeck Donaldson theorem. And this was a big news actually. And this correspondence between an analytic point and an algebraic notion was also the way that mathematicians, experts, thought would be fruitful for the problem of Keller-Einstein on Fano manifolds. So this could be motivation number one. Motivation number two, for the Keller-Einstein problem on Fano manifolds. The Yau-Donaldson conjecture was stated. Again, relating the analytic viewpoint with the algebraic one. In this case, the algebraic viewpoint is the so-called K-stability, which is more delicate than in the Kobayashi-Hitchin correspondence. And it's actually one of the delicate parts of this conjecture. The Keller-Einstein problem on Fano manifolds was still very attractive for experts. And along with the Keller-Einstein problem on Fano manifolds, probably Professor Pingali will speak about this in detail. Along with this problem, the Khler Dream also was kind of working correspondingly. And so then we can say that together there was Yao Yen Donaldson conjecture for the extremal Kähler matrix problem. So the Calabi dream became evolved in this Yao-Tien-Donaldson conjecture. Now we come to our very recent days, and probably Professor Pingali will mention this also. That the Yao-Tien-Donaldson conjecture was solved by Shushun Chen, Donaldson, and Song Sun in 2012. For Helen Einstein on Fano manifold. And the result that we want to present in the next lectures is a theorem by Shushun Chen again, and Jingri Chen of 2018. Closing the bridge for the general Yao-Tien-Donaldson conjecture on the analytic side. So it's everything for now. This is the last slide, and we will be resume after the break. Thanks.